Hi everyone, welcome back to MAM Pathshala. In today's video, we are going to see the next comparison between DED and LBPF based on the energy delivery system. So let's start today's video. So I already have discussed the beam delivery system of LBPF and DED in my previous video of beam delivery system of LBPF. Still, as a recap, in LBPF, galvo scanner and the F theta lens are two major components of beam delivery system. So the galvo scanner is responsible for the rapid movement of the laser beam over the powder bed, and F theta lens is responsible for the focusing of the laser all over the powder bed. F theta lens result in a planar focusing of the laser beam. In case of LBPF, the laser beam moves very rapidly, as I said. So the typical laser scanning speed in few thousands of millimeter per second. Whereas for DED, the laser scanning speed is in the range of few hundreds of millimeter per minute. So there is a huge difference between these two speed or scanning speed. In case of LBPF, the galvo scanner is responsible for this rapid movement, whereas for DED, the nozzle is used to deliver the laser beam and the powders as well. This nozzle is connected to the CNC, which is responsible for the movement of the nozzle, but CNC cannot deal with that high speed. So the speed is very less in case of DED. However, that rapid speed is also not needed for DED. So there is one question: why there is so much speed needed for LBPF system which is not required for DED? Is it not required for DED, or DED is not capable of printing with that high speed? So the answer is, for LBPF, the laser which is used has the focus spot diameter in few micrometer, like 100 to 120 micrometer, which is very less or lesser than the DED spot dia, which is 300 to 400 micrometer. So if I am delivering same amount of power in both the cases, for example, if the power is 400 watt for both the cases, the energy density in LBPF will be much higher than DED, because energy density or power density is equal to power by the spot area, or energy by spot area. As this diameter is so less, so the energy density or the power density will be very high in case of LBPF rather than DED. So this high energy density can cut through the build plate if the speed is lower. Our motive is to melt a very thin layer of powder over this powder bed, which layer will also have thickness of 20 to 40 micrometer. So to melt this thin layer over the powder bed, the laser's focus spot needs to move rapidly. Otherwise, it will cut through the build plate. So this is why in the case of LBPF, the speed is really high and this high speed is needed. Whereas for DED, the powder particle size distribution is bigger. So the layer thickness is also bigger. So the laser spot dia is higher to melt that bigger powder particles, and therefore the energy density is not that much or in comparison with LPBF, the energy density is lower. So I want to highlight the relative comparison between these two processes, because here the absolute value is not important. The absolute value will be important if you are talking about a particular material with a particular energy source and a particular process. So here in DED, as the energy density is lower than LPBF, so that high speed is not needed. Also using CNC, that high speed cannot be achieved anyway. So there is another question. The powder particle size distribution is higher in case of DED. So why it is higher? Is there any specific reason, or is it a limitation of the DED process? Well, it's both or it's neither. This powder delivery system is different again for DED and LPBF. We know in case of LPBF, the powder is spread over the build plate or the powder bed using a recoater, but in case of DED, through the nozzle, the powder and the laser comes simultaneously, and this powder will be delivered from a powder feeder. So depending upon the powder feeder and its capability, the powder particle size distribution is chosen. So there is another comparison and another unit that will be discussed in my next video. So now we have an idea how different and similar this DED and LPBF are in terms of energy and the energy source delivery system. But what about the material? DED and LPBF both can deal with same metal powder, but DED will need higher particle size distribution, whereas LPBF can deal with 15 to 45 micrometer powder particles and can result in micron level accuracy. So what component is fixing this powder particle size distribution? What do you think? We'll see in the next video. So we'll discuss about the material delivery system aspects. So let's meet in my next video. Till then, if you have any doubt or if you have the answer of this question, please drop it in my comment section. Till then, stay tuned and happy printing.